Okay, so we'll start tedious calculus problem solving. Case study in tedious calculus problems. More or less, we are done with multivariable calculus. There is a single variable calculus that is independent component is x-axis and dependent component is y-axis. That is what people have been seeing. This is what people are accustomed of it. Single variable calculus dy by dx. How much y is changing if x is changing? dp by dx. How much position vector is changing when x is changing? dy by dx, dp by dx. Okay, if I have x-axis and this is y-axis, then there is a graph over it, and that graph is y. The height what we see is y, and horizontal what we see is x. If at any point, if I change one unit, any point, any x point, x is algebra, means it will represent full x-axis. At any point on x-axis, at point x, if I make one unit change, then how much unit change I see along y-axis? dy by dx. If this is x-axis, this is point x, this is point origin, this is point x. At x, graph height is this one. If I move one unit, then how much height is changing? That difference in height, because of one unit difference along x-axis at any point x, is dy by dx. Okay, that is, someone would say it is as good as differentiation. Different as good as division. Differentiation is division only. Differentiation is division only. 20 by 5. 20 by 5. 20 by 5 is 4. Okay, 20 by 5 is 4. 4 means per unit change. Okay, means consider that I have two items. I have two items. One item is called mango and one item is called orange. What is division? People they do not know what is division. Very unfortunately. What is division? I have a bucket, two bucket. Okay, now I fill one orange in one bucket, and because of one orange in one bucket, I fill four mango in another bucket. Now I fill another orange in orange bucket, then I fill four mango in mango bucket. Now it has two oranges, it has it has eight mangoes. Now I fill another orange in orange bucket. I fill four mangoes in the mango bucket. I fill another orange in orange bucket. I fill four oranges in four mango in mango bucket. I fill one orange in orange bucket. I fill four mangoes in mango bucket. How much it is? Okay, it is 20 mangoes are already filled. Here 5 oranges are already filled. What is 20 by 5? I don't know what is 20 by 5. Why you are asking like that? Okay, tell me what is 20 by 5. 20 by 5 means per unit of orange, how many unit of mango are there? Mango are 20. What is mango by orange? Mangoes are 20. Orange are 5. What is mango by orange? I don't know. What is mango by orange? Okay, mangoes are 20. Orange are 5. What is mango by orange? 20 by 5. What is that? 4. What is 4? I don't know. What is 4? You asked that you what is mango by orange? I said 20 mango and 5 orange means 4. The answer is 4. What is division? Division means consider mango is M and orange is O. M by O. How much it is? 4. Okay, mango are 20, orange is 5. That is 4. What is 4? I don't know. What is 4? Okay, but you know you did division of mango by orange, right? If you do division of M by O, means you are trying to calculate number of M per unit O. unknowingly. This is called division. Division means whatever is denominator and whatever is numerator. If I make one unit change in denominator, how many units of change I see in numerator? That is division. Okay, is it a division? Yes, this is division. Now orange I can consider x-axis and mango I consider y-axis. Y-axis is dependent upon x-axis because one I increase in orange, four I increase in mango. So mango is dependent upon this. Anyway, leave it. But this is clear now. Per unit change in orange means per orange brings 4 mangoes. 20 mango by 5 means 4. This is pure division. Okay. Similarly, then what is MYO? Can I say dm by do? Certainly you can say dm by du. Division is a special case of differentiation. If I say MYO, it is same as dmydo, or better way MYDO. That is better term in differentiation. I don't know why people say dm by do. Actually, it is m by do. D we place because we are considering it as differentiation. To differentiate between normal division and differentiation, we say it is like that. Then why you go for differentiation? Why you go for differentiation? Rather, you can just divide it, right? Okay. Now consider I have this orange and this is mango. I mean, this is y-axis, this is x-axis, and orange is x-axis and mango is y-axis. Okay. Now, when orange is 0, mango is 0. When orange is 1, then mango is 1. I put one orange, then I put one mango. Now next I put one orange, next I put one orange, then I put three mangoes. I mean, I put, okay, I put two oranges. Hop. Okay, I will settle down. Okay, this is x-axis. Now when orange count is 0, then mango count is 0. When orange count is 1, when orange count is 1, then mango, earlier when orange count was is 1, then mango count is 5. Okay, orange count is 1 means orange is changing 1, the mango count is 4. Mango is constant at 4. When orange count is 1, then mango count is 4. This graph what we are seeing 4, this graph is actually d mango by d orange. Per unit change in orange brings how many unit change? So this graph, let's go in a better way. Now, this is x-axis, this is y-axis, this is origin. Now, if I have one orange, then mango is 4. I have two oranges, mango is 8. Count. I have three orange, mango is 12. I have 5 oranges, mango is 20. Okay, this is the graph now. As orange is changing, the number of mango is also changing. If I make 1 unit of change in orange, then it brings 4 units of change in mango. dy by do, d mango by do is 4. Okay. Now anyway, that I could do by division also. That is not a big deal. Okay. Now consider that at origin, my orange is 0, mango is 0. When orange is 1, mango is 1. Okay. When orange is 2, mango is 4. When orange is 3, when orange is 3, then mango is 9. When orange is 4, mango is 16. Now, now tell me how much is the kind of 1 unit change in orange brings how many unit change in mango? I don't. Truly, I don't. Okay, tell me at origin. Okay, when you are at origin, then one change in orange brings one change in mango. True. When it is at 1, then one change in mango orange brings 3 change in mango because it becomes 4. At 2, one change in mango brings 5 change in one change in orange brings 5 change in mango. Means change that we see, it is changing now. Now it is not constant. If it is constant, then division would work. Division has limitation. If change in mango per unit change in orange is not linear, if it is linear, then normal division would work. If it is non-linear, then normal division would not work. Okay, if that is the case, okay, I'll find equation now. If the number of mango, if it is x, the orange is x, the number of mango is x square. I found it. You're talking about x square, right? See, when orange is 3, then number of mango is 9. When orange is 5, number of mango is 25. Okay, tell me how much is the orange, how much is the change in mango we see when there is one change in orange, x square by x square by x. What is your y? Y is mango. Means function over x, function over orange. Mango is a function over orange. Okay. Now mango, if orange is x, then mango is x square. Earlier, orange is x, then mango is 4x. 4x by x is 4. So per unit change in orange brings 4 unit change in mango. Now mango is x square. I know it is x square. And orange is x. Per unit change in orange brings how many unit of change in mango? X square by x. The way I did last time. And it is x. Very much wrong. This is where differentiation comes into the picture. When I have denominator as a component where numerator is dependent upon denominator. Number of mango, at what point, how many mango will be there, it depends upon number of orange at that point. Earlier, it was not dependent. Kind of every time, if you add, it was not, I would say, not dependent, but not this much dependent. Linearly dependent. Here, it is non-linearly dependent. If you add one orange, then how much mango will go up depend upon the orange at that time. If orange is 3, and then you make it 4, then mango was 9, it becomes 16. Okay, if that is the case, then we say the mango equation is x square, where x is orange. This is mango. Please tell me, then per unit change in orange brings how many unit change in mango? Then it is differentiation. Differentiation of x square by, means it is, I can say pseudo division, abstract division. Okay, tell me abstract division. Abstract division is m by do or m by o anyway. How much it is m by o, but directly division you cannot do. M is x square and o is x. Direct division you cannot do. Just for abstraction, someone can write it is m by o, but don't go beyond it. Now it will fall in differentiation because they're dependent and independent and it is non-linear. Then people write it dm by do, claiming it this is algebraic and numerator is dependent upon denominator. They're not independent to each other. Then it is dm by do. Very few people know about it. Okay, or m by do. That is also m by do. If change in O brings how many unit of change in M, but it will go through not normal division, it will go through differentiation. That is M by do. X squared by dx or dx squared by dx. It is 2x. So net change in mango that is seen at any point x is 2x rather than x. Okay, can you verify? Okay, we will verify. At x is 0. When x is 0, then it brings 0 change in y. When x is 1, at that point it brings 2 change in y. When x is 3, then it brings 6 change in y. It is not that smooth the way we are expecting because we are taking a discrete value. If we take infinite value, means 0, 0.1, 0.2, 0.3 or something like that, then it will come kind of very fine, but it is all right. So at x equal to 4, at x equal to 4, the dy by dx will be 2x. At that time, we expect 8 changes. Okay, when x is 4, then it is 16. We go to 5, then it becomes 25, 9. It is close. Okay, when x equal to 8, then it will bring 16 changes. When x is 8, then it is 64. 9 is 81. 64 minus 81. 81 minus 64, it will be, I believe, 16, 17. Only one gap is there. It brings 16. So it is all right. It is far better than x. Okay, when x is 11, at that time 2 into 11. Or I can just add 1. This is what is missing. I can just add 1. That is the kind of fixed component. So if I say at x equal to 11, then it is will be 11 into 2, 2x, then 22. When x is 11, then it is 121. X 11 into 11 is 121. Okay, what about when it is 12? 144. Difference between 144 and 121 is 23. All right, right? 2x plus 1. Okay, exactly perfect. So this is brings differentiation. Differentiation is normal. Okay, can you prove the normal differentiation is different? Can you get division through differentiation? I cannot get differentiation through division. I agree. Division is only for linear, where non-linear brings differentiation. When I have to use division, when I have to use differentiation, that you tell me. You can always use differentiation irrespective of it is linear or non-linear. Division is division is subset of differentiation. Multiplication is subset of integration. So biggest term is integration. Like algebra is subset of vector. Vector is the main thing. Algebra is subset of vector. Similarly, multiplication is subset of integration, and division is subset of differentiation. Can you prove it here? Okay, okay. Anyone would say I did very perfect when one orange was 4 mango. Okay, then it was 4x by x. Simple, it came as 4. Now show it. Okay, when it is y equal to function over x and that is 4x, differentiation of 4x is 4 only. 4 only. So people can go blindly with differentiation. And then on top of it, algebra, what we are talking, better go with the vector algebra, not simple algebra, because it talks about direction also. Okay, so normal computation over algebra should be done through calculus, not through normal addition, multiplication, and division. And normal representation of algebra should be represented through vector, not through normal algebra. If I say x, then it is incomplete. It should be xi, xj, x minus I, x minus j, xk, whatever it is. Okay, if I say xi, if this is x-axis, then mango is going from here to here along the x-axis. X minus I, mango is going from here back to here. Okay, so it there we don't need any negative or something like that, and talks about the exact direction. And that is the problem in the trigonometry, like sinusoidal. People don't really understand what is sin x and whatever. Like electromagnetic radiation, it takes positive curve and then negative curve, positive curve. People, they don't understand what is negative curve. Energy is going, then it is positive. What is negative? The electric, if you see the sinusoidal electricity that is flowing in the wire at 50 hertz in India, I believe 60 hertz in many countries. At 50 hertz, so the equation of electricity that is going is something sine x. Means you take the magnitude, it will come at 220 volt or something like that. Sine x. What is x? No one knows. What is x? No one knows. What is sine x? No one knows. Just add here and there and you get sine x. If you see, then it is positive in one quadrant, then negative in another quadrant, again positive in third quadrant, again negative in the fourth quadrant. I'm sorry. It is positive in the first quadrant, again positive in the second quadrant, negative in the third quadrant, and negative in the fourth quadrant. This is the sinusoidal. What is negative? What is x? How it is going like this? No one understands it. But if I signify this sin x as a vector, sin as vector means 0 to pi by 2, it is sin x. Then beyond that, it is sin x minus I. I'm sorry, first quadrant it is sin x j, sin x magnitude, whatever is the magnitude of sin x j, j, or if it is flowing in this direction, electricity is flowing in this direction, then I, sin x, where x is the distance. Hop. If electricity is flowing at some distance, you will find electricity is reaching maximum. Then it is start reducing. So some distance, up to some distance, it is sin x I vector. Next it is sin x, magnitude of sin x minus I vector. It is going back. The electrical signal that flow like this, it doesn't flow like this. It flow like this and comes back. Flow like this and comes back. Flow like this and comes back. This is how energy moves. Because there is a media in the wire. Wire is a media, and media resists flowing the current, any energy. Any media resists flowing the energy. If I have a ball in my hand, if I have this one in my hand, then I can swing it through. Media is air. But if I try to swing it inside a sand, keep a sand and put it inside and then swing it, media is harder there. It resists. Okay, so when current is means energy is flowing through wire resists. So with the power of the, someone can say the momentum, it goes like this till the media opposes it, then it comes back. Then power is there, right? Then it goes forward, it comes back. Then it goes forward, it comes back. And this is how it proceeds. This is how energy proceeds in the wire. Okay, can you prove it? Okay, take a wire and let electricity flow in lower hertz in the sense 1 hertz or something like that. And take a point and put a multimeter out there. Okay, or disconnect it and put a current multimeter, current measurement of current out there, or voltage out there. Then you see voltage is going up, means current is flowing like this, then current is showing negative, means current is coming back. Again current is flowing, current is coming back, this is negative. Current means there is a vector involved. Vector makes anything complete. Now when it is coming back, then the sign will be minus I. It is going towards minus I axis. Minus I axis itself, it is an axis. It is not negative, it is other direction. Opposite to I is minus I. It is not, there is nothing called negative in mathematics. Everything is positive only. Only whatever is matter is direction. So sine x means, if I see the sinusoidal, sine x means it is positive direction. Negative means it is going other way. If you keep multimeter at any point on the wire, anyone can try it, then electricity will flow, it will show positive increasing current. Or make hertz like zero point 0.1 hertz, then people can watch it. Then current is increasing on the multimeter and then it will decrease. Then it starts showing negative because current is going reverse direction like that. Anyway, these are the philosophy. Anyway, the first example what we'll take again in the flux kind of situation where we were continuing the discussion in the energy calculus, commercial calculus. Commercial calculus, we consider that there is a flux density. What is flux density? What is divergence? That we please watch our previous videos. Divergence and flux density. Consider there is a flux density. Density. Flux density is how much, if there is a point through that point, how much is the liquid that is gushing out from a point. That is called flux density or divergence. Its unit is per second. There is no meter square, there is no meter at all. Its unit is per second. Unit is per second. So that is called typically called flux density or flux. If I know any point, if I know any point and I know its divergence or flux density, if I create a 3D shape around it, then how much is the actual liquid that is flowing? How much is the power of liquid that is gushing out of the point? Take a small point, like there is a fountain in a park, park where grasses are there. There is a fountain. People would have seen Omni fountain. Omni fountain. If you see, then water will gush out from all direction from that fountain, not in one direction, all direction. Now there is a point from which liquid is gushing out from here. How much is the power of liquid that is gushing out from here is called flux density. If I know flux density, that is x square plus y square plus z square plus 3, that is the flux density. Now if I have a sphere around it that has radius as 1, then how much is the liquid that is gushing out of this sphere surface? Flux density into the volume is the net flux that is coming out of it. If I tell like this also, this is enough, because we are pursuing in the calculus example, not flux. So if I have a density of the liquid that is coming out from a point, around that point if I create a surface, and net liquid that is coming out of the surface, volume of the liquid that is coming out of the surface. Okay, go on. Okay, okay, so okay, so this is centered at the origin, and at the origin, the liquid is gushing out outside, and the gushing out density is x square plus y square plus z square plus 3. Means at the origin, there is no density, but as you go along x, y, z, the density of the liquid is growing. How it is growing, God knows. But this is how the example is: x square plus y square plus z square plus 3. Now, when this is centered at the origin and it has a radius of 1, then how much volume of the liquid, meter cube per second, will come out of this surface? That is density into volume. This much I am giving. If you multiply density by the volume, then you get how much is the liquid meter cube per second coming out of it. That you get. Okay, if that is the scenario, then consider that liquid that is, consider that the density I am talking about, density is 4. 4. If density is 4, then how much is liquid coming out of it? 4 into volume. If it is 1 radius, then volume is 4 pi RQ divided by 3. 4 pi 1 cube, 4 pi by 3 into 4. 16 pi by 3 meter cube per second is the liquid that is coming out from it. Simple example. If density of the liquid oozing out at the center is 4, then how much is the volume of liquid coming out of it? That is 4 into the volume. That is 4 by 3 pi r cube. If radius is 1, 4 pi by 3. Okay, 4 pi by 3, and divide multiply it by the 4, that is the density. 4 into 4, 16 pi by 3. People also would say, you're trying to calculate the weight. Density into volume is weight. Yes, it is weight only. Okay, but it will come as meter cube per second. That is the liquid entirety in kind of what we are looking for. If density is kg per meter cube, if density is kg per meter cube, if you multiply it by the volume, it will give you the net kg, that is weight. If density is just per second, if you multiply by the volume, that is meter cube, it will give you meter cube per second. Means how much liquid gushing out of the surface is meter. If the surface is bigger of radius 2, then net liquid that will come out of it will be higher. Now the questionnaire is, now if the density of the liquid that is coming out from the center is x square plus y square plus z square plus 3. As you go along x axis, y axis, z axis, the density will grow. In that sense, if it has radius as 1, the sphere has radius 1, then how much liquid come out of it? Density into velocity. Okay, but density is function over x, y, z. The way we gave example like orange and mango. Mango is growing, but it is dependent upon x, that is orange. Density is growing, but it is dependent upon x, y, z. X into y into z constitute a volume. Volume has three sides. If I talk in Cartesian coordinate, then x into y into z gives the volume. But anyway, what is the net volume, net flux coming out of the surface meter cube per second is density into volume. So answer is density into volume. But this volume and density is dependent upon the volume. Density is dependent upon the volume, because volume constitute, if I am going for multiplication of two items, then just make sure that one item should not be dependent on another item. If it is dependent upon another item, then there is a problem. You cannot go with direct multiplication, you have to go with the integration. So the if you closely watch this, the density is function over x, y, z. X, Y, Z constitute volume. So density is dependent upon volume. If I am multiplying density into volume, then volume is independent and density is dependent. Density is mango and volume is orange. So if I multiply, then it will become density into d of V, not normal V. Like mango by orange become mango by d of O or dm by do, whatever it is. Here I won't say it will become d of density into d of volume. It is become density into d of volume. There should be kind of some synchronization between them, synergy between them, the integration and differentiation notation. But anyway, this is how it is. So now we have density into d of volume and volume from one point to another point. Like if I have oranges along x-axis and mango is collected as per the oranges, how much, how much, how much we see mango, how many mango we see when we see orange between 3 and 7. 3 and 7. Okay, then now we go for integration. We are trying to calculate the area, that is net mango. How many mango, how many mango, how many mango per orange? Then dm by do. Okay, now consider that I draw a graph where we have x-axis is orange and y-axis is change in mango versus orange. Hup, 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 hup. The x-axis is orange and y-axis is not mango. Y-axis is dm by do. Change in mango with the orange. That is the y-axis. How much is the collection I make in mango when orange is 3 to 5? Net collection is multiplication dm by do into o. This is m we want. Or if we go for integration where o into m, if I have o graph and m graph, and if I try to calculate area, then we will get m into o. Whatever people want, it is up to them. But nothing is straightforward. Either it is m into o or it is dm by do into o. Multiplication, this kind of multiplication where it is non-linear, it will fall in integration. M into O will change into M into DO. If M is x square, then integration multiplication will become x to the power 3 by 3. X square into x will become x to the power 3 by 3. Like x square by x became 2x, not x. Okay, that is differentiation. Similarly, integration. Now we have density function d of v. Density function is x square plus y square plus z square plus 3 d of v. If it is instead of v, I am saying d of v. What is v? What is the volume? That is x into y into z. D of v becomes dx dy dz. Now full equation becomes x square plus y square plus z square plus 3 dx dy dz. Now volume from 1 v1 to v2 as per the integration. Please watch what I can say previous video. Anyway, integration is division, differentiation is division, then integration is multiplication. Multiplication of two items means we are trying to calculate area where one item is x-axis and another item is y-axis. That is the multiplication. And when y-axis is dependent upon x-axis, then area calculation is not y into x, it becomes fx dx because it is different. Please watch previous videos. This is I would say past two, three videos. We have demonstrated integration in the same fashion. Now volume 1 to volume 2, density into d volume. Volume 1 to volume 2, x, y, z from x1, y1, z1 that is volume 1 to x2, y2, z2 that is volume 2. Density and dv. So what is, if I break it x1, y1, z1 to x2, y2, z2 into 3 integration, then x1 is from minus a to a. If this is a sphere, then minus a to a. Then y this side and this side. This is y and this is z top. Y is a circle. Y, if I see from the top, then it is xy plane. If I see from the top, this is z-axis, and this is x-axis, this is y-axis, this is z-axis. If I see from the top, it will form a circle on xy plane. In that sense, that circle will, x will be minus a to a, and y will be minus a square root of a square minus x square to plus a square root of a square minus x square. Z will be minus square root of a square minus x square minus y square to a square root of a square minus x square minus y square. Dx, dy, dz, x square plus y square plus z square plus 3. Okay, if that is the case and consider density is 1, then will it give me the actual volume of the sphere? Certainly. Someone can try. Anyway, we will proceed in this more, that how can we really calculate the flux with this equation x square plus y square plus z square plus 3 dx dy dz with that kind of limit. Okay, don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. We are going to bring in matrix in the next session because all these are used in artificial intelligence have matrix. So matrix is not a new thing, but it is meshed multiplication. Mesh multiplication comes matrix, and it is heavily used in OpenGL 3D graphics also. So that we will see.